Select 8 nozzles that meet the following qualifications. They have a combined output of 21.6 gallons per minute, and they can be arranged to provide the desired volume in the top and bottom half of trees. When making nozzle selections from manufacturers' tables, it helps to know the average nozzle output. Here's your calculation. Divide the gallons per minute, that's 21.6, by the number of nozzles, that's 8. Your answer? 2.7 gallons per minute per nozzle. In order to place 2/3 to 3/4 of the spray volume in the top half of the trees, the nozzles placed on the area of the manifold that supplies spray to the top half will need a combined output of 2/3 multiplied by 21.6 gallons per minute. This equals 14.5 gallons per minute. 3/4 of 21.6 gallons per minute equals 16.2 gallons per minute. The next step is to find 8 nozzles having a combined capacity of approximately 21.6 gallons per minute that can be mounted on the sprayer manifold so that approximately 14.5 to 16.2 gallons per minute will be applied to the top half of the trees. Most spray nozzle manufacturers publish tables showing the GPM capacity of various nozzle sizes for various pressures. It's unusual to have a situation where all the desired criteria can be met with one nozzle size. A situation that requires 2 or more nozzle sizes is more common. In the previous example, only 8 nozzles can be mounted on the sprayer. Then the average output per nozzle would need to be 21.6 divided by 8, which equals 2.7 gallons per minute. The manufacturer's table doesn't list a single nozzle size that provides that exact output, but the D1245 disc and core nozzle has an output of 2.69 gallons per minute at 150 pounds per square inch, which is extremely close. If 6 of these were located to supply spray to the top half of trees, the amount supplied would be 16.1 gallons per minute, or 74.5% of the total. This would be acceptable. Using the D1245 for the lower part of the tree would provide 5.38 gallons per minute, or 24.9%, which is also acceptable. Now it's time to talk about calibration. At this point, the sprayer is set up to apply a desired application rate at a desired speed and pressure. Calibration is measuring the gallons per acre of spray actually applied. Sprayers need to be calibrated to establish operating procedures that both achieve the optimum application rate and ensure this performance level is maintained. The first calibration frequently indicates that adjustments are required to achieve the desired application rate. This calibration is sometimes referred to as a trial calibration. When adjustments are made, the sprayer should be calibrated to determine if there has been a change in performance. Some refer to this step as a calibration check. The application rate is a function of sprayer output in gallons per minute and speed in miles per hour. If all the components function properly and the right nozzles are selected, only minor speed and pressure adjustments will be required. With some sprayers, only speed can be changed. The gallons per minute output required for a sprayer traveling down each side of a row and spraying a given gallons per acre rate can be calculated with the following equation. Gallons per minute required equals the gallons per acre times miles per hour times row spacing in feet divided by 1,000 again. The 1,000 is just a constant. Here are the steps for checking actual output. First, fill the sprayer with water and mark the level of the water in the tank. If a material with flow characteristics considerably different from water is to be sprayed, fill the sprayer with that material. Second, in the orchard or field that is going to be sprayed, stake out a course of several hundred feet. Also, determine the row spacing. Third, with the tractor RPM set where you want the tractor to operate, pull the sprayer over the staked out course. When the front wheel of the tractor crosses the first flag, turn the sprayer on, and with a stopwatch, start timing how long it takes for the tractor to travel the course. When the front wheel of the tractor crosses the flags at the end of the course, cut the sprayer off and record the time. Fourth, return the sprayer to the same position it was in when it was originally filled and refill the tank to the previous marked level. Record the gallons needed to refill the tank. We can now determine the speed of the sprayer, and with the information gathered, determine the gallons per acre the sprayer is delivering. Speed, miles per hour, equals course length in feet divided by time travel in seconds times 60 seconds per minute divided by 88 feet per minute. Let's plug in some numbers for the sake of example. Speed, miles per hour, equals 200 feet divided by 43 seconds times 60 divided by 88 equals 3.2 miles per hour. You can now determine the gallons per minute the sprayer is delivering. GPM equals gallons to refill tank divided by time to travel course in seconds times 60 seconds per minute. In our example, if it took 14 gallons to refill the tank, then the gallons per minute of the sprayer is GPM equals 14 times 60 divided by 43 equals 19.5 gallons per minute. We can now determine the actual output of the sprayer in our example if row spacing is 40 feet. Gallons per acre equals gallons per minute times 1,000 divided by miles per hour times row spacing. Gallons per acre equals 19.5 times 1,000 divided by 3.2 times 40 equals 152.3. Our example sprayer at this time is delivering 152.3 gallons per acre at a speed of 3.2 miles per hour. You can make minor adjustments to output, if you so desire, by changing the pressure in small amounts. This is possible only if pressure adjustments can be made on the sprayer. A change in travel speed can also change output. After making any changes, recalibrate the sprayer to determine actual output. If a grower requires 250 gallons per acre using a one-sided sprayer as in the previous example and wants to travel at a speed of 3.2 miles per hour, here's how to calculate the required GPM. Gallons per minute equals 250 times 3.2 times 40 divided by 1,000 equals 32 equals 32 gallons per minute. Now, we must select the nozzles that will give us the desired 32 gallons per acre. 2/3 to 3/4 of the output should be directed toward the upper half of the tree. Gallons per minute equals 2/3 of 32 equals 64 divided by 3 equals 21.3. 3/4 of 32 equals 96 divided by 4 equals 24. The remainder, 1/3 to 1/4, should be directed to the lower half of the tree. Gallons per minute equals 1/3 of 32 equals 32 divided by 3 equals 10.7. 1/4 of 32 equals 32 divided by 4 equals 8. The right amount applied at the right time to the right target area. That's all you need to know when applying pesticides with an air blast sprayer. With a few simple tools like a stopwatch and a calculator and a few simple equations, you can find out how to make knowns out of those unknowns, so you can get the most out of your time and money.